Hello everyone. In this video, I'm going to discuss the handout for the first experiment. So the first experiment is regarding diode characteristics. In our class, we discussed together the diode characteristics for a power diode. Today, we are going to apply this for many diodes, and we will end up with the characteristics of all of these diodes here defined in the handout. And in all of experiments guide, you need to make a formal report, and this formal report include all of the results you are going to make in lab, and include also or plotting all of curves, stipulate all of the data you recorded, and finally conclusion. You have to write conclusion and comments on all of the results given. Also, if you have any question in the handout, please solve these questions in your report as well. Okay. Reports are going to be individual, so you need to submit your report individually, not group. Okay, project only can be grouped for this class. So let's start together with the experiment here. So the objective of this experiment, guy, is to observe the IV characteristics of a diode. So the components, what we are going to use in Pspice. So this experiment today is going to be on Pspice program. I urge all of you to install student version of Pspice in your personal computer. Okay, for sure we are going to work in lab. However, it's very interesting to have this software in your computer, and this student version is for free. So it's a good chance to figure out our elements during even classes or labs or whatever, just to make experiment and see the behavior or performance of any kind of electronic elements. Okay, so the components or equipment we are going to use in Pspice today is DC power supply, diodes with different values, and some resistances according to the one we need for each diode. So we will see the circuits. So today mainly we are going to use three diodes. This diode with the serial number 1N914, 1N4002, and 1N750. So these are three different diodes. We need to make the same thing for all of the three diodes and figure out the performance of all of these diodes by the end of our lab. I'm going to make complete test for one of these diodes with you, and others you can do in the same way. So firstly, follow the procedure here with me step by step, and I'm going to apply the procedure for the diode 1N4002, and by the same way you need to make the same procedure for the other two diodes and getting the results for all. So start with number one, which is connect the circuit shown in figure 1 in Pspice schematic. So starting from scratch, how to open the Pspice schematic. So when you install Pspice, just type Pspice. You will find Pspice Design Manager. Open the Pspice Design Manager and make new workspace. So I already made the experiment, so I'm going to open or let me make a new one with you. So new workspace, you can give a name and add it in a certain place. So firstly, assume the place somewhere in your computer. So let's say I will make it here for simplicity on desktop. Okay. And with the name, let's say PR experiment 1, and create. So this is the Pspice Design Manager, Actually, Pspice, guys, is like a tree and has many pages that can be opened inside. So from the left-hand side here, you will find the first thing, which is schematic. When you press on that schematic, it will open another file here for you in order to add the elements and do your simulation. I know most of you are familiar how to use Pspice. However, maybe version to version may be different a bit. You may find some elements are exist or not exist from version to another. So we can go from scratch to figure out together how can we reach to the characteristics. So this is our schematic page. We need to have some elements. So in order to get elements, just press on draw and place part. Okay. It will give you here some predefined parameters or sorry elements I have used before. But if you can just press on the scope here to make search, okay, it will open the list in order to find any elements you need. Okay, for instance, I would like to have a diode with the number, which is, let's go to the handout again, 1N4002. So I will type 1N4002 and press. It's not found, so sometimes it needs to press D in the beginning. Yeah, so it's here. So D, which is the abbreviation of diode 1N4002. So this exists here. This is our diode. So I just will place it here, and you can find that we may place many. So we need just one. If you just need one, so just right click, and this will end your browsing. So this is our diode. If you double clicked on the diode here, you may find in the beginning you have a lot of data given. Actually, this data, guys, is made in order to create the elements. So in Pspice, we have two different ways to make coding. One way is writing code, which is writing the syntax of elements in order to add any element. And the other way is graphical, which is just inserting the elements. For sure, graphical is more simple compared to writing code from scratch. But sometimes writing code is efficient because you can modify whatever you need in the characteristics if it does not exist in some elements in the graphical way. However, for simplicity, we can use the graphical way. And by the same way, guys, you can use any kind of other simulators. For instance, Pspice, and there are some other companies are making some simulators, like Texas Instruments also has its own simulator. So whatever simulator you can use, but what I do prefer for our lab in this class, we can unify our program to have the same code for all. Even if we have shortage in one element, it would be the same for all, and we can solve or figure out how we can solve this issue. So I do recommend all of you to use the same Pspice model. So if you uncheck these two boxes, it will give you just the value that you can modify. And here for the diode, you don't have anything to be modified. So we don't need to write anything here. Okay, so this is our diode. Then we need to have resistance in series. So if we go to the handout again, this is the circuit we need to implement. We need resistor, we need supply, we need ground, and all are connected in series, as you can see. So let's go back again to the schematic. So we need supply. So again, let me press here. I need DC supply. So let's type DC supply or VDC. So I can get VDC, as you can see here. So just press place. Okay, it should be placed. Yeah, it's placed already. Okay, I need also resistance. So type R. Okay, so this is resistance here and place also. So, okay, I have to close and then press again. So this is VDC. Yeah, okay. And last thing, for any kind of circuits, guys, you have to add ground because it's going to consider ground as your zero or reference. So let's arrange now the elements and add them, connect them in series. Okay. So here, if you press here, you will get the drawing wires. So let's make wiring between elements. Okay, so we connected all of elements in series, as you can see. Now, in order to modify the values, so here VDC is 0 volt. If you double click here, again, if you include, you will find all of the characteristics. However, uncheck this will give you just the variable that you can change. So let's start, for instance, guys, with 2 volt. Okay, so I will make the DC supply 2 volt. Okay, and resistance here, for instance, is 1K, and this is our diode. How can I run? Simply, if you would like to run, you can just press here on simulate. So simulate, we need to save firstly. So let's save this schematic and save it again in the same place of the project you made. So this is our project. So save a schematic here. Now, after saving, it will make a run for this model. And you can see here another page has been opened, but it's empty. Why? I will let you know now why it's free. There is nothing here mentioned. So I would like to figure out the voltage and the current for all of elements. How can I do that? Simply, if you press V, I, it will give you all of voltages and the currents for all of elements you have, or all of branches you have in your circuit. Okay. For instance, the voltage here, as you can see, the voltage of this node is 2 volt. The current in this resistor is 1.4 amp. Sorry, milliamp. And the voltage here across this diode is 590 millivolt, and the current here, for sure, since these elements are connected in series, so you would have the same value of current. Now, can you see current is mentioned here in this figure 3 times, and all are in series, so it's not important to have all of these. So if you pressed on the element, you can enable or disable appearance of current or volt. So for instance, I'm sure the volt here is 2 because this supply is 2. So I can deactivate the current here, so it will not appear like that. And also for that volt, I can deactivate the volt of that node. I don't need the voltage here. Okay, so let's have 1 current, which is in the circuit here, and 1 volt. So even you can remove the current of this resistor. So we just have the current and the volt across this diode, which is going to be the voltage between this terminal. As you can see, this is the terminal of diode, and the 0 volt, which is here. So again, here for that one, I don't need to have this node volt. It's not important for me. I know this is 0 volt. Okay, so this would be our circuit now. What about the other page which is opened here? Actually, we have the option to show the waveform also. But in order to show the waveform, we need firstly to make simulation time and adjust transient. It's not important today to adjust transient, but just for your information, how to figure out this, just go to analyze or analysis and setup. And for setup, you need to check the transient, and in transient, you can select the time. So starting from 0 up till certain instance, which is here 1 microsecond. Actually, 1 microsecond is very small. It's okay for very high frequency, but in most of our application, we may increase this value. Okay, however, as I told you, it's not important to have graphical results today, but I'm going just to show it to you. So here I just checked. So if I run simulation now, you can find here you have axis of time from 0 to 1 microsecond. However, you don't have any results. So you can add any trace for your results. Okay, so add trace here is going to add any data you need. For instance, you need to have ID1, which is direct current, IR1, the resistor current, IV1, which is the supply voltage current, time, and so on, the different nodes, voltage, and the currents you have in this circuit. Also, you can make some mathematics or operation between different voltages and the currents. For instance, adding two voltages or adding two currents. If you have some currents or some branches are connected in parallel and you need to get the total current, so you can do the mathematical operation here you would have. Also getting the maximum or minimum value for any waveform. However, as I told you, it's not important here in our experiment today. So I'm going to cancel this, and again, I'm going to close the that screen and deactivate the other transient. It's not important in our experiment today. Okay, so now in this circuit, by the way, I can zoom in the circuit as you can see. Okay, what is needed in our experiment today? We need to figure out the characteristics of V and I, which means I'm going to change the load current of diode and record both diode voltage and current. How can I change that? I'm going to change that by changing the supply volt. Okay, so the supply volt here can be changed with any value you need, okay, in order to figure out the voltage and the current relation for this diode. However, take here, guys, in order to operate any circuit, you have firstly to look for the data sheet. So how can we get the data sheet of this element? Simply type the name of this element, so 1N4002. So you can Google it, 1N4002, and get this data sheet. Okay. Okay, so this is our diode. Okay, and this is a data sheet. In the data sheet, we'll find the maximum or average values data for this diode. For instance, this is our diode. It's written here. Let me maximize the screen a bit. So it's written here, guys, this diode has a rated volt of 100 volt, which means the peak inverse volt or the peak repetitive reverse volt can go to up to 100 volt, and the current, which is the average rectified forward current, is 1 ampere. So we can figure out the current up to 1 ampere. We are not going to increase current over rated value, and the voltage up to 100 volts. So we need to test this diode up till reaching to 1 ampere and figure out what is the voltage across this diode in order to draw the characteristics of this diode. And for sure, guys, as you know, the diode characteristics should be plotted in forward bias and reverse bias. So we need to apply positive volt and negative volt and figure out what would be the voltage and current across this diode. Okay, let's go to again to our handout. So step number 2, check the maximum current in the data sheet. So we check the maximum current according to this diode, guys, and we found that this diode is 1 ampere and peak reverse volt is 100 volt. So what would be the resistance to be added here in order to limit the current to 1 ampere at maximum volt of 100 volt? We need to calculate that. So simply, as you can see, we have just 2 series elements. The diode internal resistance is very small, so you can neglect this diode resistance compared to the external resistance of your circuit. So finally, you can say the current or the resistance can be calculated as R equals the total volt, which is 100, divide 1 ampere. So you need resistance of 100 ohm. So in order to limit the current here to avoid burning this diode, you have to add resistance of 100 ohms. So as you can see here, this is 0.1 kilo ohm. Okay, so in the simulation, you can go now to the resistance value and change this value to be 0.1 kilo ohm. Save and press OK. Now, in order to figure out the new result, press simulate again. Okay, so as you can see, at 2 volt, you have current of 12.95 milliamp and 704 millivolt. Actually, should we start with 2 volt? We need to have the characteristic in forward bias, which means starting from 0 up till increasing voltage to reach to 1 ampere. So in this case, guys, you would start from 0 volt and increasing the volt step by step up till reaching to 1 ampere or 1000 milliamp. So this is the way, guys, how we can figure out the characteristics in positive, or sorry, let's say in forward biased. So I made this test for that diode. Okay, for instance, I started from 2 here. I'm going to increase the volt, let's say 20 volts. You should start from 0. Okay, I started here from 2. So 20 volt, it gives me here 191 milliampere, and the volt across diode is 848 or 49 millivolt. I can increase the volt again. Let's say move to 100. So as you can see, the current is 990 milliamps, which is very close now to 1 ampere. Okay, so increase the volt again, assume 110 and run. So as you can see, the current reached to 1.09 ampere, and the volt here is 0.97, almost 0.97 volt. Take care. The diode average current is 1 ampere. The advantage of simulation, guys, is you can go beyond the rated values because this circuit will not be burned in simulation. However, in experiments, if you increase the voltage over certain value, over the maximum value, the element would be damaged. So this is the advantage in simulation. You can go beyond the rated values and check what would be the shape if you would increase the volt or current to a certain value. Okay, so this is in forward bias. So you need now to make a smooth curve, changing the volt from 0 to, as you can see, more than 100, okay, up till getting the current from 0 current, okay, or very few milliampere to reach to 1 ampere, okay, and then plot these characteristics in forward bias. So let's continue our procedure here. Change the supply voltage from 0 up to 100 volt in many steps to draw a smooth IV characteristics. Pay attention to reach the knee curve in forward biasing. You know, the knee curve in forward biasing is at the part of moving from saturation current to the high current, or starting moving current after the barrier volt. Okay, so you need to figure out the volt around this point or the knee curve. After that, repeat steps 4. Repeat step 4 while the diode is reverse. So you need to change the supply voltage to be negative in order to test the diode in reverse biasing. And again, change the volt for a small value up to reaching to the peak inverse volt, or even in simulation, you can increase and see what would be the performance. Okay. Question 6 here, guys. Can you reach to breakdown volt in reality? So we discussed this in our class. For power diode, we don't need to go to the breakdown volt, otherwise the diode will be burned. So you shouldn't go to that value in reality. Okay. However, in simulation, you can do that for the general purpose diodes. Okay. After getting all results, I do prefer to get the results in Excel sheet. If you would like to use any other way, it's up to you. For instance, here in that experiment, I used Excel sheet and I tabulate the results for voltage and the current in forward and bias, forward and reverse bias, and I draw that on Excel. I don't prefer drawing Excel, to be honest with you. I do prefer drawing on MATLAB. It's much easier and better, and giving better curves. Okay, and you should make this for all of tests and for all of diodes as well. So we made this now for one diode, which is 14002, this one. Okay, what you need to make after testing and getting the curves of this one. So step 8, repeat the previous steps for these two diodes, guys, 1N914 and 1N750, and observe the difference between the diodes. So you will have now like 3 tables. Each diode will have its own table for forward bias and reverse bias. Okay, and finally you have 3 curves for the 3 different diodes. Okay, and you need to write your observations. Okay, finally write a formal report including all results, all curves, and your observations and conclusions for these results. Okay, thank you so much. Please make the experiment, and if you have any question before submitting this report, you can send me an email or come to my desk in the office hours. Thank you so much, guys.